Welcome to our deep dive. And today we're going to be exploring this idea of intelligence, and then artificial intelligence, and then consciousness. And you've provided some incredible lectures for us to kind of go through everything from like the history of smart machines to even some philosophical questions about what consciousness even is. So this is going to be a very interesting deep dive.
I think it's fascinating to see how all of these different fields are intertwined, right? I mean, our understanding of human intelligence, like how does that affect how we try to create artificial intelligence? And then what does that say about consciousness itself?
Yeah. Those are great questions to keep in mind as we go through this. So maybe let's just start with the most basic question, like what makes us intelligent in the first place? We often hear those stories about these prodigies like Mozart,
Yeah.
composing these incredible symphonies when he was like 5, or John Stuart Mill, who was reading Greek at age 3. Like, what do these types of cases tell us about intelligence?
Well, I think they're fascinating and they really challenge us to think, is intelligence just this one single thing that we can measure, right? If you think about people like Kim Peek, who was, the inspiration for Rain Man, he had this incredible memory. He could remember just tons and tons of information, but, he struggled with just basic tasks. And then there were these twins who were like obsessed with prime numbers, but they couldn't even grasp basic arithmetic.
So it's like they had these superhuman abilities in specific areas, but then in other areas they weren't as strong.
Yeah, exactly, exactly. And cases like that have really pointed towards this idea of multiple intelligences, right? That maybe it's not just one single G factor for intelligence, but that we actually have different types of
So
intelligences.
it's not just about being smart or not smart. It's more about having this unique blend of different types of intelligence, like
Exactly.
a fingerprint almost.
Yeah.
And this is where like Howard Gardner's work comes in.
Right. So Gardner argued that intelligence is really the ability to solve problems or to create products that are valued in a culture, right? So he wasn't just looking at IQ test scores or anything like that. He was looking at, prodigies and people with brain injuries and even different cultures. And, one of the examples he gives is like a South Sea Islander who is navigating by the stars. You know, that's spatial intelligence, but it's not something that's going to be measured on a traditional IQ test.
So it's not just book smarts. It's more about being able to thrive in your specific environment
Hmm.
using the intelligences that you have.
Yeah, adapt, problem solve, and create things that are useful.
hmm And this is where things get really interesting when we start to think about artificial intelligence. Because, if humans have all these diverse intelligences, then can machines ever replicate them? Like, could machines be truly intelligent?
Right. And that leads us to think about things like, Deep Blue, the IBM computer that beat Garry Kasparov in chess. And that was seen as like this landmark victory for artificial intelligence. But Deep Blue's approach was really just brute computational force, right? Like
Uh,
it was analyzing millions of possible moves per second, whereas human chess players, they rely on pattern recognition and strategy.
so even though it won, it wasn't necessarily thinking like Kasparov was.
Right, exactly.
It was just doing a very, very fast calculation.
Yeah.
And this kind of brings us into like the history of AI. And it really took off with this Dartmouth conference back in 1956.
Right. So at Dartmouth, there are these two main goals, right? One was to like really understand human intelligence, and then the second was to actually build machines that could kind of like replicate that. And this led to two different approaches to artificial intelligence:
Mhm.
symbolic manipulation, or what we now call GeoAI, and then connectionism.
So Joy FAI is that basically just like using symbols and logic to try to solve problems like those early chess programs.
Yeah, exactly. And it did have some
It
successes.
did. Okay.
Yeah, GeoFAI like excelled at things like logic puzzles and playing chess because those are the kinds of things where there are clear rules and there are very logical steps to follow. However, it really struggled with a lot of tasks that humans find really easy, like, recognizing patterns or just understanding the context of a situation. Like if you think about reading handwriting, like GeoFAI had a really hard time distinguishing like different styles of handwriting, but humans can do that really easily without even thinking about it.
And that's where like connectionism comes in, right? And trying to model these artificial neural networks after how the human brain is structured.
Right. So the idea behind connectionism is that intelligence emerges from this complex interaction of many simple units. So it's kind of like, the neurons in our brains. People like Warren McCulloch and Walter Pitts, they created like the first artificial neurons. And that led to Frank Rosenblatt, who developed something called the perceptron. It was the earliest kind of neural network that could actually learn.
Oh, interesting. And how did the perceptrons actually learn?
Well, so they learn by adjusting the weights of the connections between the artificial neurons, right? So it's kind of like, strengthening or weakening the synapses in the brain. And it's this ability to learn and adapt that makes neural networks really, really powerful.
Hmm. So there's more flexibility in how they process information than with Joe FAI.
Right, exactly. But connectionism also wasn't without its critics. People like Marvin Minsky and Seymour Papert, they highlighted some of the limitations of perceptrons in the late 60s, and that kind of slowed down research in connectionism for a while.
So we had this like back and forth between like the Joe FAI approach and then the connectionist approach. And it seems like that really shaped, the early development of AI.
Yeah.
But the big question is, are brains and computers fundamentally different?
Yeah, I think that's a really important question to consider. And to answer that, I think we have to look at how the brain actually works. So in the brain, different areas handle very specific tasks. Like for example, the occipital lobe is responsible for vision. But the brain is also highly interconnected, right? It processes tons of information in parallel.
And that's very different from like the traditional computers, which are kind of processing things linearly.
Yeah, exactly.
Right.
Exactly. One step at a time.
Step by step.
Yeah, one step at a time. Although newer architectures like parallel processing are starting to blur those lines a little bit.
Hmm.
But some people argue that there are these inherent differences between brains and computers that AI can never really overcome.
Yeah. And that's where these philosophers come in, right? Like
Hmm.
Hubert Dreyfus
Right.
and John Searle.
Exactly, exactly. So Dreyfus, he argued that AI that's based solely on rules and symbols, it could never really replicate true human intelligence, right?
Yeah.
Because humans, we rely on things like intuition and understanding the context of a situation and, even our physical bodies. And those are things that AI can't really grasp.
Right. Like if you get an email that's very sarcastic,
Hmm.
a computer might take that literally,
Right.
whereas a human can tell, okay, the other person's being sarcastic.
Exactly, exactly. Like they understand the subtle cues. Dreyfus believed that those sorts of nuances were really beyond what AI could ever do.
Hmm. And then we have John Searle's thought experiment, the Chinese room. So can you maybe explain that to us?
Yeah, so imagine someone's in a room and they're just manipulating these Chinese symbols according to these rules. So they're following this program, right? And to someone outside, it appears like they understand Chinese.
Right.
They're giving the right responses, but the person inside doesn't actually know the language. So Searle used this to argue that machines can only simulate understanding. They don't really possess it.
Wow. It's a very powerful argument that makes you really think about, what does it even mean to understand something
Yeah.
and to be intelligent? And so it seems like, AI is rapidly evolving, but this debate about whether or not machines can truly think like humans, that's far from over.
Yeah, absolutely.
But this leads us to a question that I think is even more fundamental and even more mysterious, and that's the question of consciousness. Like, can we even explain what consciousness is in the first place?
Right. And that's where this idea of the hard problem of consciousness comes into play.
Okay, so this hard problem. What did Chalmers actually mean when he said that?
Well, he was basically saying that there's a difference between what he called the easy problems of cognition, like attention or memory or perception, and then this hard problem of actually explaining subjective experience. So it's one thing to understand how we focus or how we remember, but it's a whole other thing to explain why any of those things actually feel like something.
Okay, so explaining how we do something is one thing,
Mhm.
but then explaining the actual feeling of doing that thing,
Yeah.
that's the hard problem.
Exactly, exactly. So think about echolocation in bats, right? We can study their brains, we can understand how they process those sound waves, but that doesn't really tell us what it feels like to actually be a bat, experiencing the world through sonar.
Right. So even if we could map out every neuron and every synapse involved, we'd still be missing that piece. What does it actually feel like?
Exactly. And this applies to all sorts of subjective experiences, right? Like
Ah.
the redness of red, the taste of chocolate, even the feeling of love. These are all examples of what we call qualia, which are those subjective qualities of our experiences that seem to defy physical explanation.
It's like knowing all the ingredients in a chocolate chip cookie, but still not understanding what it's like to taste it.
Mm.
You can break it down scientifically, but you can't fully capture that subjective yumminess of a chocolate chip cookie.
Yeah, that's a great analogy. And that's kind of where these thought experiments come in handy, right? They help us kind of explore the boundaries of what we can understand. So Frank Jackson, He proposed this thought experiment about Mary, a color scientist who lives in this black and white world. And she knows everything there is to know about color. She's studied it her whole life, but she's never actually experienced color.
So she has all the factual knowledge, but she has zero personal experience.
Right.
So then, like, what happens when she sees a red apple for the first time? Does she learn something new?
Yeah, and that's the question. If she does learn something new, then that kind of suggests that subjective experience, those qualia, go beyond just physical facts. It challenges the idea that we can explain consciousness just by, looking at the physical structure of the brain.
So it's like she had all the pieces of the puzzle, but she was missing the picture on the box.
Right, exactly.
So are there any theories out there that actually try to explain this subjective experience, like this, what it's like feeling?
Well, there are a few. Some stick with purely physical processes, like Francis Crick. He had this theory that consciousness arises from this synchronized neuronal firing in the brain.
So it's like all the neurons are kind of singing the same song at the same time, and that creates that feeling of conscious experience.
Yeah, that's a very simplified way to put it, but it kind of captures the gist of the theory. And then you've got another theory by Roger Penrose, and he suggests that consciousness is actually linked to quantum effects happening in these tiny little structures called microtubules, which are inside our neurons.
Okay, so we're bringing quantum mechanics into this now.
Yeah.
It's getting pretty trippy.
It's getting very out there.
But, like, do these theories actually hold up?
Well, I think the challenge with both of them is that they might explain certain brain processes, but they don't quite explain subjective experience. Like, they might tell us how the brain works, but they don't explain why it feels like something to have a brain.
Right. So they're explaining the mechanics, but not, like, the magic of consciousness.
Exactly. And then there are also these functionalist theories of consciousness, like the higher order thought theory, the HOT theory.
Okay. The HOT theory.
Yeah.
How does that explain consciousness?
So the HOT theory proposes that a mental state actually becomes conscious when we have this higher order thought about it. So it's like having a thought about your own thoughts.
Okay, so if I'm thinking, wow, this pizza is amazing, and then I have another thought that's like, hey, I'm having a thought about how much I love this pizza, that second thought, the thought about my thought, is what makes the first thought conscious.
Yeah, you got it. So the HOT theory is trying to explain consciousness in terms of these like functional relationships between different thoughts in our minds.
So it's still trying to explain consciousness through, like, information processing and mental functions, but there's this added layer of, like, self-awareness.
Exactly. But even the HOT theory has its challenges, right? Like, what even constitutes a higher order thought in the first place? And, how does that lead to subjective experience?
It feels like every theory that we encounter, we hit this same wall. Like, how do we explain the feeling of what it's like to experience something? Is it possible that we're just not equipped to understand it?
And that leads us to what are called the anti-theories of consciousness. So there are some philosophers like Thomas Nagel and Colin McGinn, and they've argued that consciousness might be fundamentally beyond human understanding.
Wait, are they saying that we might never be able to solve the mystery of consciousness? That it's, like, literally beyond our grasp?
Well, their argument is that our human concepts and our ways of thinking, they're just not equipped to really grasp this subjective nature of experience. It's like trying to understand the vastness of the universe, but only using like the language of a small village. We just don't have the tools to really comprehend it.
Yeah, it's fascinating, and it's a little bit frustrating at the same time.
Yeah.
So, like, if they're right, does that mean we should just give up on trying to understand consciousness?
Not necessarily. I think these anti-theories, they highlight just how challenging it is to study consciousness, but they also kind of encourage us to think outside the box. Maybe we need some totally new ways of thinking, new scientific paradigms to like really crack this code of consciousness.
Yeah. Like, we need a whole new language to even talk about.
Exactly.
So even if we don't have all the answers right now, just like grappling with these questions, I think it really expands how we think about the world.
Yeah, it really makes you wonder about like the limits of what we can even comprehend. It really does. I mean, that's what I love about exploring these topics. It's not always about finding like a concrete answer. Sometimes it's just about asking the right questions, pushing the boundaries of what we know.
Well said. So let's take a moment to kind of recap this amazing journey that we've been on. We started by kind of, challenging that traditional idea that intelligence is just this one, single measurable thing. And we looked at Howard Gardner's theory of multiple intelligences.
Right. And then we jumped into the history of artificial intelligence, starting with, Deep Blue beating Kasparov at chess. And we talked about that debate between symbolic manipulation and connectionism.
Mm-hmm.
We even touched on, the arguments from some people who are skeptical of AI, and they question whether machines can ever really truly think like humans.
Mm-hmm. Mm-hmm. And then we went even deeper and we explored this hard problem of consciousness.
Yeah.
We looked at those thought experiments, like Mary, the color scientist. We even thought about those philosophical zombies. And we, wrestled with all these different theories that try to explain what it's like to experience the world.
We even got into that pretty mind-bending idea that maybe consciousness is just beyond our current understanding. Like, we might need a whole new way of thinking about it to even approach the problem.
I know. It's been a lot to process, but I think it really highlights how all of these ideas like intelligence, AI, and consciousness, they're all interconnected. Understanding one can give us insights into the others. And I think after this deep dive, you're really well equipped to have those conversations, to understand those different arguments and then even form your own conclusions.
Yeah. And then just remember, it's not just about, memorizing all this information. It's more about how it makes you think about the world differently.
Exactly. And so as we wrap things up here, I want to leave you with just one final thought. We've explored all these theories, all these different ideas, but the nature of consciousness, it still remains this profound mystery.
Mm-hmm.
And so I'm curious, what do you believe about consciousness? Do you think it's purely physical, or do you think there's something more to it?
As you go about your day to day, just pay attention to your own experiences, all those sights and sounds and feelings, those are all expressions of consciousness.
Mm-hmm. Something that we often take for granted.
We really do.
But it's like the most incredible thing ever. And this deep dive has given you the knowledge. Now it's up to you to continue exploring.